Welcome to the course Sustainable Farm Design in Developing Countries. This course derives from the project called Intelligent Infrastructure Design for a Multifunctional Efficient Farm, also known as iFarm, which aims to reduce poverty and malnutrition in sub-Saharan Africa areas isolated from cities. Particularly, this project foresees to fulfill this objective through the construction of low-cost and low environmental impact travel infrastructures, namely bridges and roads, the design and realization of a solar photovoltaic plant for supplying domestic loads in island conditions, the design of smart refrigerating chambers supplied through a microgrid from renewable sources, that is, photovoltaic panels and biomasses. In details, these engineering works are in view of the realization of multifunctional farms, which should be independent, with a low environmental impact, and allow the circulation of zero food mile. The three objectives deal with the improvement of the travel system of the involved area, as well as the development of technically advanced working and storage method for the farm products using sustainable power supply. A remarkable productive efficiency benefit is expected due to the improvement of the production of food, its conservation and transport to the neighboring city. Thus, food should be available at affordable prices even for the poorest urban population. These lectures aim to present some simplified approaches to be applied for fulfilling the goals listed before, minimizing costs and environmental impact to be consistent with the functional needs of the considered geographical area and preferring the use of material available on site. Students will acquire specific technical competencies applicable to similar contexts in analogous geographical areas. The methods presented in the following lectures are appropriate for macro design through guided procedures based on simplified equations and free open-source softwares. The course is organized in weeks, and each of them proposes 2 lectures. Week 1 is devoted to civil structures, namely some technical procedures for low-cost and low environmental impact design of bridges and roads are presented. On-site material and resources are involved in the realization of interconnected structures between cities and isolated areas. Optimized solutions in terms of costs and realization time are studied by evaluating the specific type of soil, the presence of waterways and their levels, the expected traffic, and the working habits and techniques typical of the considered area. Week 2 focuses on the structures for energy supply and harvesting. Particularly, the 2 lectures are about the design of a photovoltaic power plant disconnected from any distribution grid for supplying mainly domestic loads. It is necessary to design the panels such that the autonomy of the load is guaranteed, given the weather data of the geographical area under investigation. The supply system is designed referring to the state-of-the-art for panels and battery, aiming to minimize the realization costs. Week 3 foresees lectures on the design of a refrigerating chamber for food conservation. Compared to similar products available on the market, this device is inserted into a microgrid and it has the following innovative aspects. It integrates 1 or 2 renewable power sources combined with batteries, and therefore it can be doubly fed. It has smart features for monitoring the connected power supply, and it allows it to move from another energy sources if needed. Thus, the working cycles of the system are optimized, being capable of minimizing the power consumption and related costs. The lectures are supported by links and/or manuals of the suggested open-source softwares, but also by a proposed exercise based on the sizing result of a pilot site on Pangala Farm developed within the iFirm project. Hence, students can test the acquired competencies on a real case study.